Hi, this is Josh with another tutorial video from linear algebra. Here today for this video we're going to discuss the inverse of a matrix and some coding skills for the TI-84 plus CE calculator. And here again I'm using the SmartView software for this calculator, and so let's get started. So the first thing we're going to do is we're going to pull up the matrix menu. And we'll do so by doing second and this key here, x negative 1, which is the inverse function. Whoa! What happened to second? Oh, there it is. And there's the matrix menu. Okay, so I've been working with a few of these problems for a while here. So there are 10 cells that are reserved for these matrices. And so I just emptied them out except for the first matrix, and here we have a square matrix that's 3 by 3. So 3 rows and 3 columns. So what I'm going to do is I'm going to create matrix A so we can find the inverse of this square matrix. So I just type them in row by row, 1, 2, 3, 2, 5, 6. And then for the third row, 3, 4, 9. Okay, so then if I do mode clear, I can go back to the calculator screen. And then if I do second matrix, just type in enter or 1. And then square bracket A, square bracket, hit enter. And that's the matrix that I just entered for square matrix A, that's 3 by 3. So the next thing we need to do is we need to check if this square matrix has an inverse. So the way you do that is you do second matrix, and go to the second column of functions, determinant, transpose, dimension, fill, identity, and if you go down, we'll do the reduce row echelon form. That is, we can swap rows, we can add them together, we can multiply them by a scalar, we can subtract them, a non-zero scalar. And we'll try matrix A and see what the reduced row echelon form is. All right, so what we want this matrix, when we reduce it, using our row operations, our elementary row operations, it'll be the I3 matrix. So it'll be 1, 1, 1 along the diagonal from upper left to lower right, and all the other cells will be 0. So when we reduce this matrix, there's 1, 1 in place. But here, this cell needed to be 1, and it's not. So it's 103, 01, 000. So that is not I3. So therefore, this matrix does not have an inverse. So what I'll do now is I'll go back to the matrix menu, and I'll edit that matrix again. And there it is, just as I typed it in. And I'll go down to this cell, and I'll change it from a 9 to an 8. So then, same thing, go to the second column. Let's do the reduce row echelon form of matrix A. And it's the same matrix here, but I changed this 9 to an 8. Okay, so for that set of cell values, for those rows and columns, that matrix does have an inverse. So the next thing I'm going to do is I'm going to use the I3 matrix. This is a 3 by 3, order 3, the I3 matrix, and I'll store that answer into, let's see, there's my matrix A. I'm going to store it into matrix C. Sorry, hold on just a minute. Dimensional mismatch. So I need to do answer, store button, which is this arrow here in the lower left, excuse me, matrix C. There it is. So now if I code in matrix 3 or C, hit enter, it will bring up the identity matrix. So if you've studied inverse matrices, there are two main methods here to well, this is the main method that's taught in classes. I'm going to take matrix A and matrix C and combine them into one large matrix. So matrix A is 3 by 3. This is a 3 by 3 matrix, so I'm going to create an augmented matrix. So again, that's in the second column, and it's function 7. So I'll take matrix A, comma, matrix C, and then I will store that as matrix. Well, since I'm working with these square matrices here, I'm going to put the augmented matrices down below. I'll put it, I want on the same screen, so I'll put it as matrix H. Okay, so now this is matrix A, here the first 3 columns, and this is matrix C, A, comma, C. So then if I call out matrix H, it will produce this matrix. So this is A, and this is I. So the method that you should be familiar with is we use the same elementary row operations. We can multiply by a scalar, a non-zero scalar. We can swap any 2 rows, or we can add or subtract any 2 rows and replace. So we're going to reduce this. We're going to, from AI, make the left side I3, and that will create our inverse matrix, which will be shown on the right. So I'll do the reduced row echelon form of matrix H, the 3 by 3 matrix, 3 by 6 matrix, and matrix A is now reduced to I3 by elementary row operations. The identity matrix has now been replaced by, this is A inverse. So what I need to do now is I need to store the inverse matrix into matrix B. All right, so I will use the calculator again and bring up matrix A, which is here. So that's the original matrix, and here is the inverse. So the way you can do that with the calculator is you can do matrix A, and then that key that gets you to the submenu, just press that -1 like an exponent. Okay, but that's the notation for inverse functions, which you should have learned in trigonometry in Algebra 2. And then there it is. Should be the same matrix as above, and it is. If we go scroll up. So those are the same rows and columns. So then I'll store that as matrix B. So take the answer, store it into matrix B. And so it'll automatically change the rows and columns. So let's see what we have so far. So matrix A was the matrix that I entered, where I changed the 9 from a 9 to an 8 in the lower cell. Matrix B is now A inverse. Matrix C, this square matrix, is I3. And then here below I have the augmented matrix, which was the classroom exercise. You take both square matrices matrices A and C, and then you reduce it and you get matrix B on the right. So there is a method of storing and a square matrix and its inverse. Okay, the other thing that can be done here is you can take the original square matrix A and we can extend it. Okay, so I'll extend it and I'll add extra columns to it. So I can add any number of extra columns I want to it. So what I'll do is I will create a matrix D. So let's say I'll have 3 rows and 2 columns. So these can be any values, so I'll do 0, 1, 2, 3, 4, 5. Okay, so now what I'll do is I'll again show, here's my original matrix A. Here's this new extended matrix P. Notice that it's not square. So when I augment these matrices, can have augmented matrix AD. Before we used augmented matrix, square matrix A with its square identity matrix, so it was 3 by 6. This will be 3 by 5. So going to augment matrix A, comma, matrix D, and then I'll store that as matrix. I have my augmented matrices down here, so after H at matrix I. So here we have augmented matrix I. So not all square matrices have an inverse. Remember, we had to change the 9 to an 8. But we do have something useful here with extended matrix P. So now the matrix has 3 rows and 5 columns. So what we're going to do is we're going to reduce the matrix A to the identity matrix, and we'll produce another matrix here on the right. So this 2 by 3 matrix is serving as A inverse B. Okay, in the other matrix we had AI, and then we created IA inverse. So I'm going to store these cells into its own matrix. It's also 3 rows by 2 columns. So I'll store that as matrix E. Okay, so the properties of these matrix extensions. Okay, so now we have the original square matrix, but these added columns, these added 2 columns, are that if we take A inverse, which we know we can reduce to the identity matrix, so I guess I'll take A and we use AD reducer, we got E. So that means if I take A inverse, which is B, and multiply it by D, we should get matrix E. There's a 3 by 3 times a 3 by 2, 3 by 2. So it's the outer 2 numbers. 3 by 3 times a 3 by 2 will give us a 3 by 2 matrix. So matrix B, which is the inverse of matrix A, times matrix D gives us matrix E. Matrix A times matrix E will give us matrix D. The other thing to note is that We started with the concept that not all square matrices have inverses. Some matrices that are not squared do have inverses, but not all. And here we've shown that if I take matrix A, I multiply it by, the inverse of matrix A and multiply it by this extended matrix, we get matrix E. If we take the original matrix and multiply it by the extended inverse, we get matrix P, that extended matrix. So thank you for this introduction to matrices, and I'll be doing more videos, and I'll put together some videos with some applications and uses of inverse matrices. So thanks for watching and happy studying.